Good morning, everyone, and welcome to today's webinar, Stone Mastic as an Ungrooved Runway Surface. By way of introduction, my name is Sam Layton. I am the Regional Airports and Industry Development Manager here at the AAA. Today's webinar will cover topics such as runway surface requirements, traditional grooved dense graded asphalt, other asphalt mixtures, stone mastic asphalt, development of a specification, and review of the Emerald Airport runway surfacing project. Today's webinar will be presented by Dr. Greg White. He is the Director of the Airport Pavement Research Program at the University of Sunshine Coast. These presentations take time to prepare, and I'd like to thank Greg for preparing for this webinar today. Most of you will already know Greg, but a little about him. Following a career as an airfield engineering officer in the Royal Australian Air Force, Greg worked for a number of leading Australian design consultants as a principal airport pavement engineer, and then as the technical manager airports for one of Australia's leading airport construction and surfacing companies. As always, the opportunity to ask questions will also be provided. To ask Greg a question, please type your question into the control panel and press the send button. They'll all be answered at the end of Greg's presentation. So without any further ado, I'll now pass you over to Greg. Thanks, Greg.
Morning all. I'm just making sure that I've got the IT sorted and about right. Hopefully you can hear me and see my screen. Thanks Sam for the nice introduction, and of course the AAA for having us along today. Stone mastic asphalt as a ungrooved runway surface, something that has been ongoing for a year or two now, and has attracted a significant amount of interest from lots of different parts of our industry. Find my controls. As many of us would know, there are about 400 airports in Australia with what we might call paved or sealed runways. A whole bunch of those have got spray seals in the regional airports. Most of the others have got a grooved and dense graded asphalt surface. In America, New Zealand, South Africa, and the UK, they predominantly used grooved asphalt as well. They don't generally put spray seals on their runways. That's quite an Australian thing to do. Most of us would be familiar with grooves. We usually install them 6 to 10 weeks after the surface is built. In that period in between, our compliance is questionable or marginal, because we need the grooves before we'll comply. We know they're expensive. A significant airport could spend $500,000 putting grooves on their runway after they've resurfaced it. They can close in under traffic in hot conditions, and they can complicate maintenance in terms of rejuvenation or preservation treatments. They don't make those things impossible, but they certainly make them a little bit more complicated than they would be. So something like stone mastic asphalt, which allows for ungrooved runway surfaces, is quite an attractive option, and it's quite common in Europe and China. In fact, I was telling a young engineer from an aeroplane engineer from Boeing not so long ago, from Virgin not so long ago, that if they're flying to Beijing and Shanghai in China, they've already landed on stone mastic asphalt as a runway surface, as an ungrooved runway surface, because China's got about 40 runways with this on it, including Shanghai and Beijing. So what's this? So today we'll talk about what this SMA stuff is and why we're doing this now. A few people have said to me, gee, how long has it taken to get to this point? And there's a few reasons for that. Talk a little bit about its use and experience around the country, particularly the Emerald Airport project. A couple of other projects that have come along since, and I've discovered since, some conclusions, and then of course we'll answer those questions at the end for those who have them. The stone mastic asphalt, we call it stone mastic in America, they call it stone matrix asphalt. It's just another kind of asphalt. It was originally developed in Germany, primarily for resistance to damage under studded tyres that they like to use on their vehicles when it's snowing, for a bit of extra grip. and to break up the ice. It has a different grading. So essentially the only difference between stone mastic and our normal airport asphalt is the distribution of the size of all the aggregate particles in there, and therefore an increase in the amount of voids in between those aggregate particles, which we then fill up with a bit of extra bitumen and fine material. So it has a higher fine content, so the dusty part of the mix, there's more of that, and it's got more bituminous binder in it than our dense graded material. One of the real misconceptions that I've found in talking to people about this stone mastic stuff is the belief that it's porous, and it's not. So there are actual porous types of asphalt. They're generally called popcorn mix or open graded mix or an open graded friction course, and they are designed to be porous so that if you tip some water on top, the water will disappear into the asphalt mix and it will actually travel through the mix and be discharged through the edges of the pavement. That's how those mixes are designed to work. Stone mastic isn't like that, because we fill all those voids up with extra bitumen and extra fine material. So it looks quite porous on the surface, but I'll show you some data later. It's definitely not a porous material. So this little table just summarizes the differences between stone mastic and the dense graded asphalt that we're all used to. It still comes in 7, 10 and 14 millimeter sizes, which really is just the biggest stone in the mix. You can see the extra bit of binder in there, the bitumen part, 6.2 versus about 5.6%. Less air voids, so there's actually less air voids in the mix than there typically is with dense graded asphalt, which is one of the reasons why it's impossible for it to be porous if you've done it right. Because of all that bitumen, we have to put some fibres in there. The idea of those fibres is that they stop the bitumen from pooling at the bottom of the mix whilst during transportation. And because we need all these extra fines to fill those voids up, instead of using hydrated lime, like we would usually use in airport asphalt, we use crushed limestone. And we use the crushed limestone because the percentage of lime is so high, about 5% versus 1%. If we put 5% of hydrated lime into any bituminous or asphalt type mix, we'd make a very stiff and brittle mix. So we use a different kind of lime, crushed lime, instead of that fine powdery lime that we might be used to. This just shows the grading. So in the red line there, you've got the normal dense graded. So this is just the distribution of all the particles in terms of the aggregate pieces, and then the SMA envelope from a draft specification in the blue lines. Highlight two areas. The area on the right just shows the SMA is missing a whole bunch of particles sort of between about 5 and 10 millimeters in size. But at the other end, on the left hand, at the tail, on the left hand side, you can see the additional fines that we use to fill the gaps up. And the gaps between the big particles are created by that missing section in that sort of 5 to 10 millimeter size particles. So that's the physical difference between the two mixes. In terms of what they look like, this is a bit of a schematic that we'll talk about Sean in a minute, but this was really his project from a couple of years ago, developing a lot of this stuff, including a draft specification. So he put these together to show schematically the difference between them. And when you take a couple of cores out, these came from the project at Emerald, you can see the difference. So on the left, you've got the SMA, you've got a lot more bitumen, and you're missing a lot of those middle-sized stones. And as a result, you get the surface texture that you get there, which is quite open and porous looking. But if you look at the mix itself, it's there's no interconnection between all of those air voids that you can see at the surface. They don't penetrate through the mix. It's a very dense mix with very low air voids, and of course the dense graded core on the right hand side, which is, as we'd all be used to for those of us involved in resurfacing runways on a regular basis. So why are we doing this now? Most of you would be aware that in 2018, we developed what's now known as the APA performance-based asphalt specification. In part of that process, the asphalt contracting members that contributed to that kept asking, what about other mix types? When can we get away from the old dense graded volumetrics? How can we incorporate that? Because we don't have a good test to check the durability of the mix in terms of its risk of losing stones and creating FOD. We don't have a good test for that. So we need to maintain or retain an existing composition or type of mix. So we could have stone mastic because it's existing and we've got confidence in that volumetric composition, the stones, the grading, the bitumen content. If we just left that open, we would need a test to make sure that we're not going to generate too much FOD by making a really coarse and harsh mix. And we don't have that test at the moment, so we couldn't go down that really performance-based line. SMA was the logical choice. There are a couple of other options like the open graded friction course, but just based on our circumstances in Australia, what we want to achieve out of this process, and its use internationally, stone mastic was the most logical of those options. Sean Jamieson is an Air Force airfield engineer. He was seconded to the university in 2018 to do a master's project. He really developed the draft specification. He did laboratory trials of 7 different mixtures with the assistance of the asphalt contractors, the big asphalt contractors that do most of our airport work around the country. And he also managed to get the Air Force to fund a trial on a taxiway at RAF Base Amberley, which was quite useful for his project as well. So we had in 2018 the APA spec really begging the question, what about these other mixes? Then during 2018, we had Sean's project to do essentially the science behind all of this and put some of this stuff together. A few pictures from Sean's project, including bottom center photo is the trial that was done at RAF Base Amberley. And as far as I'm aware, still looking as good as the day it was put down, which would have been late 2018, November or December, I think. I think the AAA National Conference actually might have been on at the time that was done, or very close to it. Before stone mastic is embraced or accepted as a new normal within the airport industry, a number of questions needed to be answered, practical questions, such as, do the asphalt contractors have the ability to make this stuff? Can we make it in the drum style asphalt plants that we commonly use to resurface our runways? Will it perform as good as dense graded in terms of rut resistance, crack resistance, resistance to moisture damage or stripping? Of course, most importantly, will ungrooved SMA meet our skid resistance requirements in the moss? Because if it doesn't do that, then there's no point in doing any of this. In fact, even further than that, would the friction be as high as grooved dense graded asphalt friction? And in the end, is it economical? And we'll talk about the economics at the end. In terms of skid resistance, we'd all be reasonably familiar that CASA effectively mandates ICAO advice, which is to either have 1 millimeter of surface texture or friction, wet friction, commonly measured with a grip tester, but there are other machines, or be grooved. And of course, ungrooved SMA isn't going to be grooved, so it needs to either have 1 millimeter surface texture or friction levels above the recommended ICAO levels. Or preferably, it will have both of those things, and we'll get to some data on those things later. I just wanted to re-emphasize, if we didn't meet this, then ungrooved SMA really wasn't ever going to be viable. In terms of, does our industry have the capacity to make and pave this stuff? Every state in Australia has a road specification for SMA. And in fact, if you line up the draft specification that Sean put together and many of these road SMA specifications, particularly the one from New South Wales and the one in Queensland, they are very, very similar. They're really the same asphalt, just with a few extra tests, because we're airports and we feel a little bit warranted in really the extra few tests that give us that confidence that our asphalt surfaces are going to be good on our runways. So clearly the industry has the ability to make and pave these things because they do it every day on main roads in Queensland, in South Australia, in Western Australia, in Victoria, and in New South Wales. As I said before, China's got more than 40 runways surfaced with this stuff. Germany's got a few, so have Norway and Spain. Buenos Aires in Argentina also has ungrooved stone mastic asphalt on its runway. So clearly, this material can provide an appropriate runway surface. So all we were really trying to do was put these two sides of the triangle together to form the third side, which is Australian runways or Australian airports having stone mastic on their runways, knowing that our local contractors could produce it and knowing that internationally it had been deemed a suitable runway surface. So that brings us to Emerald Airport. Emerald Airport had a really old dense grade asphalt surface. It was in dire need of resurfacing, as well as a bit of strengthening at about 200 or 300 metres of each end of the runway, which were clearly built as extensions sometime in the past, and just weren't as strong and performing as well as the central portion of the runway. I happened to be advising on their resurfacing project, and we had a discussion one day about grooving and wouldn't it be great if we could do this job without grooves. I said, oh gee, I've got this student doing this really interesting project. He's nearly at the end of it. You have the opportunity to be the first airport to embrace it and to implement it. They thought that was a pretty interesting idea. We did quite a bit of homework. It wasn't a light decision that that Central Highlands Regional Council made as the owners of Emerald Airport. We actually tendered both options and evaluated and weighed up the pros and cons of each in quite some detail. But as it turns out, Boral was awarded the contract as a ungrooved stone mastic asphalt project. GHD performed the on-site and the contractual administration part of the project for the council. Emerald Airport, nice red dirt out there, very dry, very typical of a regional airport in Australia. One significant runway, one quite small GA type secondary runway, a couple of taxiways, and 5 or 6 parking bays for on the RPT apron, something like that. In terms of so this is a bit of data now from the Emerald Airport project. So everybody in our asphalt industries familiar with these Marshall properties. We use them both in mixed design and in quality assurance of all of our airport overlay jobs, and most of the road authorities use them as well for their asphalt mixtures. All I really wanted to do here was highlight the fact that stone mastic isn't going to have the same properties as dense graded asphalt in terms of stability and flow. So you can see there the dense graded values that we'd be more used to in red, and you can actually see there you've got just get a little. You've got sort of data around the 13, 15 kilonewton stability mark and flows of around 2 to 3 millimeters on this side. Because of all the extra bitumen that's in the stone mastic, the stability drops down to 8, 10, which you technically, well, is lower than the values that are in our traditional airport asphalt specifications, which are generally above 12. On the flip side, this flow property increases, again, because of all the bitumen and the elastic bitumen generally that's in this mix. So it's, in this case, increased from sort of 3 to 4 up to about 5.5 to 7. So quite a significant increase. And if you're very used to seeing the dense graded results, then those numbers might come as a bit of a shock to you. But as we'll talk about in a second, those things aren't necessarily detrimental. Here we have the performance test results from the mix design at Emerald Airport, and because Emerald Airport had a lot of dense graded and a lot of stone mastic in the job, because there was aprons and taxiways and some shape correction layer underneath, we got quite a bit of data on both types of mix using the same aggregate made in the same asphalt plant, mixed, designed by the same asphalt technician. So it was a good comparison. You can see there that our performance properties in terms of the wheel tracking for deformation resistance, the cracking resistance, the moisture damage or stripping resistance, they're all almost identical. Certainly they're so close that any differences are just random, and they're not actual real differences. The actual real differences are the stiffness. So the SMAs has a lower stiffness, about 1200 megapascals compared to about 1900 for the dense graded. That's again largely a function of the extra bitumen that's in the mix. But in this case, this was being used as a surfacing layer, which is where stone mastic should be used. It shouldn't really be used as a structural layer. As a resurfacing layer, the modulus is less important than if it was being used as a structural layer. But of course, on the flip side, and the most important property of SMA is this 1.4 millimeter surface texture. So that was tested on slabs prepared in the laboratory, 1.4 millimeters, dense graded. To be honest, we didn't test the dense graded surface texture, but we know from experience that it's always between about 0.4 and 0.6 of a millimeter. So I just average those and call it 0.5 for the purposes of this comparison. So excellent performance relative to the dense graded asphalt that we're all used to. A little bit less stiff, that's okay because this isn't structural. But on the flip side, the surface texture that we need to meet CASA skid resistance regulations and requirements. I won't go into them here. I have done that elsewhere and it'll be presented and published elsewhere, but I won't go into it here. But we looked at all of the asphalt production results to make sure that the drum plant that we use commonly on our airport resurfacing jobs was making the stone mastic as well and as consistently as it was making the dense graded. And the Emerald Airport was terrific at allowing this comparison because it had the same aggregate, the same binder, produced in the same asphalt plant. Statistically, the production of the two mixes was almost equally consistent. I think that's the right language, but certainly there was no alarm bells jumping out saying, hey, this stone mastic stuff, it doesn't get made in this drum plant very well. The only really thing of any that's even worth commenting on was that the binder content that we measured each night was a bit more variable for the stone mastic than it was for the dense graded. But it's because all this extra bitumen gets stuck on the tools that the lab technicians use to split the samples up when they're doing this testing. And they actually have to scrape that off essentially by hand and distribute it amongst the different samples. And then if you get that wrong, because it's essentially a manual process and it's all sticky and gooey and a mess. If you get that wrong and you put a bit too much bitumen in that sample and not enough over there, and then you test that one over there, it'll look like it's devoid of bitumen. But it's really a testing issue as opposed to an actual difference in the material that was being produced. So I was quite comfortable that we could make this stuff just as well in our drum asphalt plants that we use on most of our remote airport resurfacing projects, as we've traditionally been able to make our dense graded asphalt. which is an important thing. So out in the field, after we've paved it and compacted it, we've tested the air voids, we were quite interested to understand and make sure that that difference in the air voids at mix design time was also being reflected in the field. And again, the stone mastic is in blue, and the dense graded that we're used to is in red. The red dashed lines represent the limits, and you can see there that both on the mat, so away from the joins, and on the paving joins, the SMA had slightly lower air voids, about between 0.5% and 1% generally. There was just one little non-compliance where the air voids actually got down to about 1.7%, but that was one result out of about 300 results, I think, from memory. Lower air voids, but still within these limits, can only mean a more durable surface. And so the expectation is that that at Emerald Airport, the SMA will actually outlast the dense graded sections on in terms of taxiways and apron pavement, which were still surfaced the way we always have with the dense graded mix, but of course not grooved. The Boral at Emerald also took the opportunity to do a check on this porosity or permeability issue. So you can see there as you move from the left-hand side to the right-hand side along the horizontal axis, you've got samples that have been prepared at increasingly higher air void contents. And when you get to about 6.5% air voids, then all of a sudden the permeability or the porosity of the mix goes up, and you can start to get water infiltration through the mix. So as long as we're below 6.5% in the SMA, it's very much an impermeable material. And you can see there, I've just drawn a couple of statistics out of the quality results. 94% of the air voids in the SMA were less than 5.5, and even on the joints, 70-something% of them were below 6.5, and in both cases, that was better than the dense graded results in terms of air voids and percentages of air voids below sort of that 5.5 to 6.5% value. So this, to me, this puts to rest any concern that this stone mastic, even though it looks quite porous on the surface, could in any way allow water to enter and move through it, or through its entire thickness anyway. Surface texture, we tested that at Emerald on every night, 10 times per shift. From the trial, we did a construction trial of the two types of asphalt, dense graded and stone mastic, side by side, and that trial, the results from that trial are on the left, and you can see there, as I suggested to you before, the dense graded in that sort of 0.4 to 0.6 range, whereas the SMA, we had one at 0.9, but the rest were sort of 1.1 to, I think, up to 1.4 or something by the looks of that there, or thereabouts. During the project itself, so on the right-hand side, we tested that 10 times per shift, and I've just done a little histogram there of what the surface textures were and how often, and you can see that the vast majority are somewhere between 1.2 and 1.5 or 1.6. I think on average we were about 1.4 something, which is exactly where we wanted to be, comfortably above 1, but certainly not getting close to 2, because there's just no need to be that high. So we just wanted to be comfortably above 1, which we were, and so we were quite happy with that. In terms of friction, now a little bit of a busy slide. So you got the 65 km/h test on the left and the 95 km/h test on the right, which is how we normally test friction. We've got the green, the yellow, and the red lines. So really, what we wanted to be was above yellow in all cases. And again, the blue line is the SMA results, average results. The red lines are the dense graded average results, tested at different days. We actually tested the runway there, particularly the trial section. Day 1 day, 17 days, 60 something days, and about 158 days after the trial was built. The trial was built 2 days in a row, stone mastic one day, dense graded the next, or the other way around. So you could see there, and the most important lines are these blue lines, the blue line in relation to the yellow dash line, which is the maintenance intervention level. You see there that we had compliance from day one, whereas the dense graded was really marginal on the first day. We did these extra couple of tests, and by about here I was getting a bit nervous because we were headed towards the yellow line. But after that, we started to see the bitumen wear off the top of the stones. And when we went back after about 3 months, we were off the chart kind of friction. In fact, the friction testing technician said that that's the highest values of friction he'd ever tested on a runway. And of course, not grooved. I've also separately analysed how much the friction increases when you groove a runway, a dense graded runway, and it goes up by about 10 to 15%. So I've actually added 10 to 15% to the dense graded numbers, and they're still not as high as the stone mastic numbers were. So I'm quite confident in concluding that through its entire life cycle, the stone mastic will have equal or better friction than grooved dense graded asphalt is expected to have, which is great. That's exactly what we want. Texture above 1 millimeter and friction better or similar, at least, to grooved dense graded friction. So perfect outcome. Couple of photos from the job. You can see the surface there in the top right. The finish runway remarked in the bottom right, and of course the paving operation on the left. Job went pretty smoothly. There were challenges, as there always are, but I think generally it went quite smoothly. I think Boral are quite proud of what they did, so they should be, and I think Emerald Airport would say that they're quite happy with the outcome. In terms of the economics, and I've really simplified this and tried to take out some of the first time risk premium that I think would reasonably have been built in to try and get a true apples for apples comparison of the cost. And as I said at the start, we actually tendered both options at Emerald, so that gave us a really good way of comparing these things. The SMA costs more to make because it's got these fibres in, and because it's got about 0.5% more bitumen in it, and bitumen is the most expensive part of any asphalt mix, always more expensive than the aggregate. On the flip side, this more expensive asphalt production cost is offset against the savings because you don't have to groove the runway. In the case of Emerald, it actually cost about $400,000 more, or about 4%, to use the ungrooved SMA. So the little table down the bottom says that if both surfaces last 10 years, and 10 years is what I would advise any airport to base their long-term forecasts for expenditure on, particularly for a grooved dense graded runway, then the ungrooved SMA cost 104%, 4% more than the grooved dense graded asphalt costs. But as I said at the start, we've got all this extra bitumen and we've got lower air voids, can only mean that we're going to get a longer life out of this. And we'll talk about some experience later on about why we believe that's a justified statement. But for now, I'll just say that a big study in America that compared stone mastic to dense graded asphalt mixtures in roads and in airports, a massive study, they concluded that SMA on average lasted 4 years longer. So if we assume that our SMA at Emerald will last 14 years, and that the grooved dense graded asphalt will still last the standard or the normal expectation of 10 years, then the SMA on a whole of life basis will only have cost per year 75% of grooved dense graded. And in fact, you can see here, even if the SMA only lasts 11 years, just 1 year extra, that it's already providing a 5% per annum saving compared to the grooved dense graded. So there are a lot of assumptions in there, and you have to take a whole of life view of things. This was the kind of thing that Emerald Airport weighed up in deciding to do what they did. I'm quite confident that it's valid, but there are a lot of assumptions that go into these kinds of calculations. I think it's been said a few times that that Emerald Airport was the first airport in Australia to be resurfaced with SMA. We have to admit a couple of things in hindsight. Cairns used SMA on its aprons and a couple of taxiways since 1998. So Emerald can still believe that they were the first runway in Australia to have SMA. However, a couple of weeks ago, I went to Latrobe Airport in Eastern Victoria in the Gippsland, lovely little place. And I was there looking at a PCN assessment for them. And what do you know? Their runway is a 10mm sized SMA, I believe, to a road specification. It was surfaced, that runway was surfaced in 2015, so 5 years ago. So I'm not so sure that Emerald can claim to have been the first anymore, or they were certainly the first to do it to an airport-specific performance-based specification. So I guess the more constrained you make yourself, the easier it is to have been first. But technically, I now believe that that Latrobe was technically the first runway in this country to do it. I'll show you a photo from Latrobe in a minute. Shell Harbour, which has been previously known as Wollongong and Albion Park airports, it thought this was such a good idea, and they were quite jealous that they didn't beat Emerald to it. But they resurfaced their runway in March this year with stone mastic asphalt to the same specification that Emerald used. It was a bit different. It wasn't a strengthening thing. Didn't have a lot of shape correction to do. It was just really a 45 to 50 mil nominal thickness resurfacing, which is actually where in a closed airport continuous runway closure environment. So the work was done in the day. It was quite a busy week, but it was quite an enjoyable week. And I think that they too would be the first to say that they're quite happy with the outcome that they got. In their case, incidentally, it saved them about $150,000 compared to the grooved dense graded. There's a photo from Cairns Airport. It's apron parking positions and at the north end of the domestic apron. There's this line here, red line, that I've superimposed on top of this photo. If you go and physically look at it on the ground, Steve Willis has got some paint markings down here that tell you that on this side of that line is dense graded asphalt, and on this side of the line is stone mastic that he did as a trial in 1998 because he thought it would be a good idea. And you can see there, I know it's probably hard to see over the internet, but all of that colouring in that area is all crack seal, and on this side there's virtually not one bit of crack seal anywhere to be seen. So that's 20-odd-year-old asphalt, 23 years old, 22 years old. Same plant, same aggregate, same everything the same, except on the left-hand side dense graded, and on the right-hand side stone mastic. Of course, this is an apron, so this was never grooved, but it does show the improvement in durability and crack resistance of the stone mastic mix compared to the dense graded mix that was produced with the same materials in the same plant. As I mentioned, Latrobe Airport, 5 years old, plenty of surface texture, even though it was only a 10mm sized mix rather than the 14 that we've used at Emerald and at Wollongong since. Not one crack. I could hardly see a joint. They've got no maintenance to do on a surface that's 5 years old except to repaint the lines, which of course isn't a stone mastic issue. I think they've got at least another 10 to 15 years out of that surface, which is well above the average in terms of runway surface expectations in the current climate. So a good result for them as well. I mentioned Shell Harbour, just in terms of their mixed design numbers, the contractor used a harder, stiffer binder, so their wheel tracking was down and their fatigue life was slightly lower, 31%, and that's a reduction from the initial stiffness due to the fatigue damage. So a bigger number is actually a worse number, but we're targeting not more than 50, so 31 still a good result. Wheel tracking at 1.1 millimeters is excellent. You can see there with that stiffer, harder binder, the modulus or the stiffness of the mix goes up, so more suited to a structural type layer. Again, we tested surface texture on essentially a daily basis or each lot of asphalt basis. 1.4 millimeters was the average surface texture, and that project actually saved in the tender box as an alternate offer $150,000 or thereabouts, which was in the order of 3% of the cost of the resurfacing. Obviously, their project was a lot cheaper than the Emerald project, and that's really just circumstances and size and number of tons that the job had in it. A few photos, generally pretty good weather, a few clouds on a few days, but yeah, again, excellent result. Very low air voids numbers throughout the job. So everybody's pretty pleased, I think, with that. So in conclusion, I thought it would be easier just to try and answer those questions that I put to you at the start as being essential for making this thing essentially accepted as a normal practice. Can industry do it? Yes, it's common on roads. They do it all the time. Can we make it in a drum plant as opposed to a batch plant, which has more controls? The drum plants are very common in Australia. Batch plants are more common in Europe. Yes, we did it at Emerald. Statistically, what we produced at Emerald, the SMA was no more variable than the dense graded mix, with the exception, as I said, of that bitumen content, which really is about how you test the material as opposed to how you produced it. Does it perform like dense graded? Well, based on those lab tests, yes, in terms of deformation resistance, crack resistance, moisture damage resistance, yes. But it has that increase in surface texture to get you your 1 millimeter. And based on my estimates of the additional friction associated with grooves, then the SMA is going to have a level of friction that is comparable but probably higher than grooved dense graded runways. Economically, to build it, it's marginal. So we've had an example now where we saved 3% at Shell Harbour, but it cost us an extra 4% at Emerald up front. But if you take a whole of life view and you accept that it's going to last somewhere between 2 and 5 years longer, which is the best estimate that we have at this point in time, then you'll get your money back down the track because you're going to extend that period between resurfacing, even though it might cost you a little bit more or a little bit less at the time that you actually do it. The specification is now available. We've used it on 2 projects. I'm sure there'll be more in the future. As I said, if you include the Latrobe experience, there's been 3 projects completed. Skid resistance is compliant on all 3 of them. We've observed comparable performance to the dense graded mix, and we're expecting it to last somewhere between, well, maybe 2 and 6 years longer, but we'll see how we go. The experience on that apron at Cairns is quite compelling in terms of the improvement in surface texture or surface erosion, and also in terms of cracking, and therefore the need to seal cracks. The economics are going to depend on the job and the location of your airport, because of that need to import fibres and also to import that crushed limestone. But if you look on it in terms of look at it on a whole of life basis, then there are significant cost benefits, probably for most areas in Australia where limestone's reasonably available. And I can put my hand on my heart and say to you honestly that if there is a reason for an airport to resist putting stone mastic on their runway, I don't know what it is yet. We might find one down the track, but as of today, I can't figure out what that reason might be. And that should bring us, oh no, not quite to the end. So there's always a catch. As I said, if you're in a really remote area where you've got to import that crushed limestone, then the economics are going to, you're going to be at the extreme worst case potentially of those economics. The other catch is that our dense graded asphalt, we're pretty happy putting that anywhere between about 40 millimeters thick and 80. With the SMA, that width or that variability of comfortable layer thickness reduces a bit down to about 45 to 60. That's just the nature of the material. So if you've got a big shape correcting job to do on your runway, as opposed to just a surface replacement, then you might end up using a few more tons to do it in stone mastic than you would have if you'd done it in dense graded. And on Emerald Airport, that cost a couple of hundred extra tons of asphalt because they did have some shape correction. So some areas that could have just been done in one layer with dense graded up to 80 millimeters thick needed to be done in 2 layers, a dense graded layer and then a stone mastic layer over the top, which complicates the construction a bit, but certainly it's manageable. The only other catch is this binder drain down. I mentioned to you about the fibers to try and stop this from happening, but even with the fibers, if you fill up a whole bunch of trucks at the start of the night before you start resurfacing or paving the asphalt, then the first truck is at risk of some of this binder pooling in the bottom of the truck because it's going to be standing around for probably a couple of hours until it actually gets used. The photo on the right shows an example that is from Emerald Airport. There were 3 of those, I think, from memory. They were all the first truck of the night. But in total, that has affected about 3 square meters of the 80,000 square meter runway at Emerald, and they've just been left in place. They haven't been treated. If you do a sand patch test on them, the texture isn't as high as it should be. But 3 square meters out of 80,000 square meters isn't something anybody's losing any sleep about, not at this point in time anyway. It's just something that needs to be managed. Incidentally, at Emerald, once this became apparent, the contractor changed their processes. Boral was quite proactive. They changed how they were loading the trucks up at the start of the night, and generally we didn't see that happening anymore after those first couple of shifts. Again, there's my contact details. Contact me anytime. I'm going to try and hand my screen back to Sam, I think, who might help us out with any questions that have come up.
Thanks so much, Greg. We do have a fair few questions. That was a great presentation. Thank you. The first one we have is from Andrew, and he asks, can you use adhesion agent instead of lime in the mix?
So traditionally we used lime and it was mandated, and that was as much about moisture damage resistance as anything else. That was in our traditional dense graded mix. The performance specification that's now published by APA went away from that and said as long as you achieve the outcome requirement in terms of moisture damage resistance test results, then we don't mind whether that's with lime or with an anti-stripping agent or however else you want to achieve it. And that is generally still the case in the SMA specification. The complication with the SMA is because you need all that extra fines, you're going to have to find them from somewhere. So crushed limestone is one place to find them. You might choose to find them with other source of fine material, and if you do that, then certainly it's not mandated that you include lime hydrated or crushed limestone in the SMA specification, as long as you meet all those other requirements, which we've tried to make as outcome or performance based as we possibly can.
Thanks, Greg. There's another question from Con, and he asks, he 100% agrees with your comments about hydrated lime. ground or crushed limestone. Unfortunately, some SRA are insisting that 1.5 HL as anti-stripping is incorporated in SMA regardless of the type of filler. This, as you rightly point out, will make the mix a lot more difficult to work with and compact. What do you think about that, and how do we get through to SRAs?
Well, I don't need to get through to state road authorities because I work in the airport space. But I guess that's a philosophical issue about whether your specification is performance based and outcome focused, or whether it's prescriptively based. Certainly, if there was interest, I think we could gather up some data in the road SMA or dense graded space. You could you design mixes with and without hydrated lime. You could show that the performance through the various tests we have available, like the TSR, is no different, or it's comparable, or it's better, or whatever the case may be, and the results would speak for themselves. But I guess one of the blessings that we have in the airport space is we don't have a lot of regulation in terms of our specifications and our materials. So we've been able to achieve things like performance-based asphalt specification and stone mastic on a runway relatively simply and efficiently. I think that the bureaucracy that comes with a state road authority probably makes it a bit more challenging in that environment. But I think the principles are the same, and I'm happy to have a chat about it offline if Con wants to be in touch.
Thanks, Greg. On to the next question from Filippo. The surface texture is not dissimilar to the coarse gradation super pave mixes we trialled in New Zealand in 1998 to 2006 and could comfortably meet friction test requirements without grooving. Those mixes were difficult to compact during placement. The SMA high bitumen content is very attractive from a longevity and resistance to weathering effect. What is the modus stiffness of the SMA mixes versus DGA?
So we saw in there that when we used the same binder and the same aggregate, the SMA had a stiffness of about 1200 MPa versus 1900 MPa for the dense graded, just because of all that extra bitumen. It's probably worth noting as well, my understanding anyway, not that I had a lot to do with them, is that some of those New Zealand runway mixes that were provided under the super pave brand, for want of a better term, were actually quite porous and were letting moisture into the mix. And that, so really comparing those two things, it was almost like a third type of asphalt that was being used. It wasn't really dense graded the way we knew it. It wasn't SMA. It was sort of something kind of in between, maybe a little bit more porous. So I didn't have a lot to do with those. So. But certainly we had no trouble at Emerald or at Shell Harbour achieving compaction, and you saw the air voids results somewhere between 0.5% and 1% lower in the SMA, so clearly we were compacting it quite well.
Thanks for that, Greg. The next question is from Daryl, and he says, hi Greg, on the SMA performance you showed texture depth of 1.4 millimeters. Usually the texture gets better over time with SMA, but do you think there is anything that could see this reduced to below the 1 millimeter STD, as a 0.4 millimeter buffer, is not a lot?
Well, actually 0.4 of a millimeter is quite a lot in terms of surface texture depth. There's a big difference between 1 and 1.4, and there's a really big difference between 1.4 and 1.8 in terms of how things look. You think that how much grooving changes the look of your runway surface, and it's adding effectively kind of like adding about 0.6 of a millimeter, 0.6 to 0.8 of a millimeter. So those numbers, even though they're quite close together, they're still a long way apart in terms of practical outcomes. Certainly there's the potential that the stone mastic surface will close up a little bit under lots and lots of traffic. So the stones might roll over and bed themselves down a little bit nicer. And that could potentially reduce some of that texture. But I think on the flip side, just the natural erosion of the surface over time would probably largely offset that. I guess the reality is we'll only know, but certainly the surface at Latrobe, which was 5 years old, I didn't test it, but visually it looked like it had plenty of texture in it, although that's only lightly trafficked. And certainly the apron at Cairns Airport, which is 20 odd years old, has it's probably getting closer to 2 millimeters texture depth by now. So I'm not losing sleep over that, even though I don't have a lot of data to support it yet, because we're still in the early stages. Even well, with the exception of Cairns, we're still only 5 years into the process, if you count Latrobe.
Thanks, Greg. We now have another one. With the extra binder in SMA and the stiffness being slightly lower than DGA, how do you think it will perform as the binder ages and oxidizes and becomes stiffer?
Well, we know that oxidization and stiffening is really only occurring in the top 5 to 10 millimeters of the surface. So I would imagine that profile would be very similar for dense graded and for stone mastic. I don't think the stiffening over time would be substantially different, just because it's stone mastic and it's got a bit more bitumen in it, about 10% more, I suppose. So an extra 0.5%. If anything, the extra bitumen also increases the film, the binder film thickness. So the thickness of the binder that's around every stone, and that extra thickness should reduce the effects of any aging or oxidation over time. So I don't. It's probably not the most scientific of answers, but I don't think that's going to be noticeably different from our current mixtures in terms of stiffening up over time.
And another one, how does SMA perform under rainfall events with relatively flat grades on runways when compared to a grooved runway?
Well, in both cases, the grooves, or in the case of SMA, the surface texture isn't predominantly there for drainage in terms of the whole pavement draining. It's really there to allow an escape path for the water that is trapped between the tyre and the pavement surface. So I suspect that in very heavy rain, that grooved, dense graded asphalt would still perform better in terms of shedding water away, just because the grooves are like little channels, as opposed to the surface texture being sort of randomly provided around the pavement surface. Having said that, most of our airports don't really groove for wet weather friction. They groove to meet CASA's regulatory requirements. So we're essentially grooving most of the time because we can't achieve 1 millimeter surface texture. So as long as the SMA achieves that, then CASA effectively are deeming for us that whether you're grooved or have a millimeter surface texture or you meet friction, from a skid resistance perspective, you're equally compliant, and therefore the three parameters are considered to be interchangeably acceptable, whether they're actually physically the same in terms of aircraft performance in wet weather braking is probably a different question. And I'm sorry, I don't have that great an answer, although I do note that the friction values were, and I quote the friction testing technician, the highest friction values he'd ever seen on a runway. And that was a friction test in wet weather, which is probably more relatable to wet weather aircraft braking than surface texture on its own might be. So I hope that helps. I don't know. Yeah, needs some more thought, I think, that one, Sam.
Okay. Given SMA is not porous, in a deluge, what is the difference in drainage capacity on an SMA non-grooved or a grooved runway surface, and how does that impact friction in that situation?
Yeah, so that's really the same question, just asked in a different way. Again, we've still got minimum and maximum crossfalls on runways for overall drainage. The function of your grooves and the function of the 1 millimeter surface texture in SMA isn't about overall drainage. It's about localized escape paths between the tyre and the pavement surface. And again, our regulations essentially treat those three different things: friction, texture, and grooving as equivalent, whether they're physically equivalent or not under an aeroplane in wet weather, I guess is a different question. But from a compliance perspective, we can meet any one of those that we choose, and as long as we maintain it and continue to maintain it through the life of the pavement. Yeah, so again, probably needs a bit more thought in terms of physically how they actually compare, but from a compliance perspective, they're all equally valid.
Thanks, Greg. For SMA as a surfacing of a new runway, what would the pavement structure look like generally? Do we need a dense graded asphalt layer below SMA? In China, the SMA runway pavement structures are typically 60 mil SMA, 60 to 120 mil DGA times millimeter base.
Yeah, so yeah, I think that what's driving China and Europe, I would imagine as well, if we looked at it, to put thick, dense graded asphalt under their stone mastic is just their approach to pavement design. So even if they had dense graded surfaces with grooves, they would still have lots of ungrooved, dense graded mix below it. So I don't think that the pavement structure necessarily needs to change, although I do think that a second layer of asphalt underneath the SMA would make a lot of sense. One, because it'll just provide a nice sound hard base to put the SMA on. It'll also take out any roughness in the underlying base course and essentially provide a nice smooth surface that doesn't require any shape correction. Now, having said that, there were parts of the Emerald Airport that we were paving SMA directly on base course, not in large areas, but certainly in some areas, and we didn't have any issues there. In fact, the construction trial at Emerald Airport was a mill and fill into a spray sealed runway, an old spray seal surface. So it was all in directly on the gravel. The Shell Harbour job, and I have no doubt Latrobe as well. I know Latrobe was different, sorry, but certainly the Shell Harbour job that's been done since was directly on a spray seal, so no asphalt underneath. So a reasonable quality gravel with a spray seal, and then the SMA on top of that. It didn't seem to cause us any concerns or any issues. So I don't really think the principles are any different than they are with dense graded surfacing. And I think China having lots of asphalt underneath its SMA is a different issue. It's not SMA driven, it's just a different approach to pavement design like they use in America.
Thanks, Greg. Given that it's 12 o'clock and I am conscious of everyone's time, we'll just ask one more question, and then I will ask that anyone that has any further questions to please contact Greg via his contact details that were flashed up on the screen earlier. If you didn't write those down, please contact me, slayton@airports.asn.au, and I can forward those to you for any additional questions. So the last question of the day is, Greg, great presentation. Unless you already covered it, does rubber build up as fast, and how does it perform under rubber removal? Oh, I beg your pardon, sorry, it says unless you cover it, does rubber build up as fast, and how does it perform under rubber removal?
Yeah, to be honest, I don't have a great answer to that question. I guess I take a lot of faith in the fact that there are lots of runways, particularly in China and Europe, that use stone mastic. They'd be generally busier than our airports here, certainly busier than most of our airports here in Australia. So I take a bit of, I guess I'm taking a bit of a leap of faith in that if rubber or rubber removal was somehow uniquely problematic for SMA, that they would have let us know that by now, or it would be written down somewhere in the international literature, or it would at least be enough of a problem that we would have found out. But I'm certainly conscious that grooves collect rubber quicker than ungrooved dense graded asphalt does. So I think SMA is probably going to collect it at a rate that's less than grooved dense graded, but probably faster than ungrooved dense graded. But of course, ungrooved dense graded wouldn't comply with our surface texture requirements, so it's really not an option for us in these days.
Thanks, Greg. So as I mentioned, it has hit 12 o'clock and I am conscious of everyone's time. So today's webinar recording will be available in Airport Alert and emailed to everyone directly once available. We encourage you to provide feedback on any other topics that you would like to see covered in the 2020 webinar series. Please email events@airports.asn.au. Thank you once again to Greg. Great presentation, always super popular and very informative. We look forward to our members' participation in our next webinar being held on Wednesday, the 24th of June. It will be presented by 270 with the topic being emergency management at Australian airports. Enjoy the remainder of your afternoon and week. Take care. Are you there, Aaron?